Unit GC2 Controlling Workplace Hazards. Element 1. Impact of temporary works. Key information: temporary works include short-term building projects, maintenance, renovation, demolition, excavations. Sites where temporary works take place can become unsafe owing to the presence and use of machinery, vehicles and electricity. The hazards of demolition and excavations include collapse of structures, collapse into excavations, falls, flooding and hazardous substances. Striking buried services, for example electrical cables, gas pipes, etc., can be avoided by obtaining plans, then locating and identifying buried services prior to digging. Main hazards and controls relating to temporary works. Temporary works may include the following types of work: short-term building projects, maintenance, renovation, demolition, excavations. Sites where temporary works take place contain examples of all of the hazards that are present in other workplaces, particularly construction sites. There are also a few hazards that are specific to temporary works. Building, maintenance and renovation. Building, maintenance and renovation work involves the use of hand tools, portable power tools, such as chainsaws and disc cutters, and machinery, such as bench-mounted circular saws and cement mixers. It also involves the use of vehicles and plant such as dumper trucks, forklift trucks, mobile cranes and excavators. Work equipment. We will describe the hazards and controls relevant to hand tools, power tools and machinery in Element 4, Work Equipment Hazards and Risk Control. So here we will briefly cover some of the hazards and control measures related to one specific type of equipment, cement mixers, as well as some other general control measures for the use of work equipment. Hazards associated with cement mixers include entanglement with rotating drum and internal blades, entrapment by belt drive. Dry cement dust can be inhaled. Wet cement dust is corrosive and burns the skin. Cement mixers are powered by diesel with the resulting risk of exposure to vapors and exhaust gases. Noise and vibration. Overturning while in use. To summarize the control measures needed when using equipment, site management should ensure that equipment is suitable for the task and environment. Use is restricted to competent operators. Information, instruction and training are provided. Equipment is inspected and maintained in a safe condition. Appropriate guards and devices are fitted and used. Appropriate PPE is used at all times. Vehicles. Element 2. Transport hazards and risk control contains more specific information on transport hazards. Here, we will briefly consider some hazards arising from the use of two examples of vehicles used in temporary works, forklift trucks and dumper trucks, and appropriate control measures. Forklift truck hazards include collision with structures and pedestrians, poor visibility, especially when reversing, noise and vibration, overturning. Dumper truck hazards include collision with structures and pedestrians, overturning on slopes and the edge of excavations. Poor maintenance, unauthorized use. To summarize the control measures needed for the safe use of vehicles, site management should ensure that the site is carefully designed and laid out to allow safe movement of pedestrians and vehicles around the workplace. Designated pedestrian walkways and vehicle routes are provided, with appropriate markings, barriers, signage and lighting for each. Vehicles are suitable for their intended use and environment and are maintained in safe working order. Drivers are appropriately qualified, medically fit and given information, instruction, training and supervision. Close supervision of vehicle movement is critical on building sites, and banksmen should be used whenever vehicles are moving in congested or busy areas, or reversing. Site security. Building sites and areas of maintenance and renovation are inherently dangerous places. They can also act as a lure for unauthorized visitors, such as members of the public taking shortcuts, a public right-of-way possibly going through the site, thieves entering to steal plant or equipment, children drawn by curiosity, Good site security is therefore important, especially when the site is in an urban area. Topic focus. Possible options to secure a site against unauthorized access include robust perimeter fence and signs, secure gates at all site access points, security staff, perhaps 24-hour cover, good lighting on site and on the perimeter, CCTV cameras and/or site alarm. Secure all portable equipment in locked storage. Remove ladders from scaffolds. Secure all chemicals in locked storage. Secure all mobile plant. Cover or barrier off excavations. Where children are concerned, it can be useful to liaise with local schools to promote safe behavior. Where there is a public right-of-way through the site, then every effort should be made to barrier and sign the pedestrian route. Electricity. The hazards and controls relevant to electrical safety are described in Element 5, Electrical Safety. To summarize these controls briefly, site management should ensure that site electrical distribution systems are suitable for purpose and the site environment. The various protective systems available, such as fuses, earthing, low voltage, for example 110 V, and residual current devices, are used. User checks, formal visual inspections and combined inspection and testing are carried out on portable electrical equipment, as appropriate. In particular, temporary electrical distribution systems on site should be designed and installed by a competent electrician and protected from physical damage by suitable positioning, use of conduits and armored cable. Temporary works such as building, maintenance and renovation often bring workers and plant into close proximity with electrical distribution systems. There are two main ways in which electrical shock accidents can occur: proximity to live overhead power lines and contact with buried services. Remember that high voltage electricity can arc through the air, so contact with an uninsulated overhead power line is not necessary for an electrical accident to occur. We will deal with the hazard of buried services later, in the section on excavations. Accidents associated with proximity to live overhead power cables can be prevented by isolating the power supply when working in the vicinity of power lines. If power cannot be isolated, it may be possible to sleeve low voltage power lines. Using safe systems of work, SSW, and permit systems to control access into danger areas. Using barriers, signage and goal posts to keep plant and vehicles a safe distance from power lines. Using banksmen when plant is maneuvering near power lines. Using non-conducting equipment, such as fiberglass ladders. Demolition. Demolition involves knocking down buildings to clear ground, but it also includes smaller works in maintenance and renovation, such as the dismantling of parts of structures, for example one part of a steel-framed building, or the removal of walls, for example to create open-plan rooms. The hazards associated with demolition are very similar to those encountered in other types of building work, with a few additions. Demolition hazards vary depending on the nature of the work, but typical hazards include premature collapse of structures, work at height, plant and machinery, contact with live overheads, contact with buried services, asbestos dust, movement of vehicles, explosives, noise and vibration, hazardous substances, which may be present from previous use of the building, biological hazards from vermin or stagnant water, sharp objects, including glass and nails from the demolition, or syringes left by trespassers. Manual handling. The controls and precautions are therefore also similar to those that apply to other types of building work. Typical control measures include careful assessment and planning of the work to eliminate hazards where possible, for example selecting a demolition method that keeps workers away from the immediate area, such as a long-reach machine or a crane and ball. Elimination or control of work at height, see earlier. Structural surveys to assess strength and stability of the structure and adjacent structures. Propping and supporting may be necessary to prevent collapse. Assessing the strength and stability of floors to ensure that plant, Machinery and debris placed on them do not exceed the floor's tolerance. Disconnection of services, for example gas, electricity, water. Removal and disposal of any hazardous materials, such as asbestos, prior to demolition. Securing the site with fencing or hoardings to create a buffer zone and exclude unauthorized people. Damping down with water spray to reduce dust creation. Excavations. The hazards of excavation work include, collapse, when the unsupported sides of the excavation slip and cave in. Severe crush injuries can result from even relatively small collapses because soil is very heavy. Workers buried or entrapped in soil can asphyxiate in minutes. Workers do not have to be completely buried for asphyxiation to occur. Being buried to the chest will lock the rib cage and have the same effect. Striking buried services, when high-voltage electrical cables, gas pipes, mains pipes or other buried services are struck during the excavation work. This can lead to electric arcing, shock, burns and fire, or gas explosion, or rapid flooding of the excavation, not to mention major business disruption to service users. People falling in. When people fall into the excavation from an unfenced edge or while climbing into or out of the excavation from ladders. Objects falling in, when tools or materials fall from an unprotected edge into the excavation and onto occupants, vehicles driving close to the side of the excavation. Spoil, loose soil, piled close to the sides of the excavation. Flooding from surface water during heavy rain, groundwater, or a ruptured water main. Hazardous substances, in particular gases and vapors. Excavations will fill with any gas that is heavier than air, such as LPG and carbon dioxide. Adjacent combustion engines, such as generators and compressors, can act as a source of exhaust fumes. The ground surrounding the excavation may contain methane or hydrogen sulfide, both produced by microbial decay, which can leach out of the soil and into the excavation, or be contaminated with hazardous materials as a result of previous activities. Excavations might need to be classified as confined spaces for these reasons. Collapse of adjacent structures. In digging and excavation, the foundations of nearby buildings may be disturbed, resulting in the destabilizing or collapse of the structure. A shallow excavation revealing a collection of buried services. Prevention of collapse. The collapse of the sides of the excavation can be prevented by battering. The sides of the excavation can be sloped back, battered, at an angle that is sufficiently shallow that the soil will not slip. Shoring. The sides of the excavation can be supported, shored, with metal or timber that is fixed in place inside the excavation. Trench box. The sides of the excavation can be temporarily supported by a metal box that can be lifted into the excavation and moved along to give a protected work area. The type of protection method used will vary depending on type of substrate that is being excavated into. Length of time the excavation will be open for. Type of work to be carried out. Groundwater conditions and potential for flooding. Depth of excavation. Number of people in the excavation. Prevention of falls. Preventing people from falling into the excavation can be achieved by use of barriers. Barriers should consist of guardrails, as for a scaffold work platform, to prevent people falling in, and toe boards to prevent objects being kicked down into the excavation. Good lighting, both within the excavation and at the edges, and signage should be provided. Long excavations should be provided with crossing points, bridges, that should be similarly guarded in with barriers and toe boards. Access to the excavation should be achieved by properly positioned and secured ladders. Ladders should extend 5 rungs above the edge of the excavation to give a secure stepping-off point. They should be routinely inspected. Preventing material and vehicles from falling in can be achieved by maintaining a safe distance from the sides of the excavations. Spoil heaps should be positioned a safe distance from the excavation sides. Vehicles should be prevented from approaching the excavation sides by use of barriers and signage. If vehicles have to approach the sides of the excavation, for example to backfill, then stop barriers should be positioned to prevent vehicles from rolling in, particularly important when vehicles are reversing. Vehicle movement close to unsupported excavations must be minimized to prevent the side of the excavation from becoming loose as a result of vibration. Workers in the excavation should wear hard hats to protect them from falling objects. They should also wear steel toe cap boots. Prevention of striking buried surfaces can be achieved by using safe systems of work in combination with detection equipment. Plans of the area of the excavation should be obtained. Plans do not necessarily show the exact position of buried surfaces, but can give an indication of the existence of surfaces and an approximate position. The buried surfaces should be located using surface clues and detection equipment. Various devices can be used to detect different types of surface, such as metal detectors, hum detectors, cable detectors, ground radar. The buried surfaces should be uncovered by careful digging by hand. The exposed surfaces should be identified to ensure that they are those that were expected and be clearly labeled so that their position is easily seen. It may be necessary to support pipes, for example gas pipes, where ground underneath is being removed. Digging with mechanical equipment can now commence. Hazardous gases and vapors may require that the excavation is classified as a confined space, in which case a specific confined space risk assessment and SSW will need to be developed. The excavation should be made subject to a permit to enter. Forced air ventilation, air monitoring and respiratory protective equipment may be necessary. Inspection requirements. Excavations, like scaffolds, can become unstable and unsafe if not maintained in good order. They can deteriorate rapidly as a result of environmental conditions and are liable to catastrophic failure. It is essential that they are inspected routinely to ensure they are in a safe condition. Excavations should be inspected by a competent person, before the start of every work shift. After any accidental fall of material. After any event likely to affect strength and stability. Records of these inspections should be kept on site, and remedial work must be undertaken as soon as possible to repair any defects noted.